All right, so now we're going to do this problem. What's the pH of a water that's that has 25 degrees C with 0.5 milligrams per liter hypochlorous acid? Go ahead and hit those lights for me. Thanks. This is example problem 10-1 in your book. Blank this guy. There it goes. Okay, so we said that the temperature is 25 degrees C. The concentration of HOCl is 0.5 milligrams per liter. That's what this means when it says that the concentration of hypochlorous acid is that. We can write it this way. And we're going to find the pH. Okay? So part A of this, we'll break it down into 3 parts. We're just going to convert milligrams per liter to moles per liter. When we're doing pH, we usually need it in molar units. So 0.50 milligrams per liter. 1 millimole of this material is 52.5 milligrams, and then we'll unit convert from millimoles to moles, and we'll get 9.52 times 10 to the negative 6 moles per liter HOCl. Okay? I'm sorry, this was actually B. Part A should have been, we're going to use Appendix 5 to get that the pKa is 7.54 at this temperature, okay? And so if the pKa is 7.54, then the Ka is 10 to the negative 7.54. You guys remember pKa's and Ka's, right, from chemistry and other classes? I hope so. Okay, now we're gonna, part C then, we're gonna write the equilibrium expression. The reaction that we're talking about is HOCl in equilibrium with H plus and OCl minus. Ka is the equilibrium expression. H plus OCl minus over HOCl. And here we're going to assume that the H plus is equal to the OCl minus. This is the part, this is what we can do because we're ignoring the dissociation of water, okay? In reality, we got to take into account the whole acid-base equilibrium. But we're going to assume for our purposes that H plus and OCl minus are about the same, which would be accurate for, you know, moderate pH range. Okay. Our new Ka then, we can write H plus squared over HOCl. And therefore, H plus is going to be the square root of Ka times the HOCl concentration. H plus then is going to be square root of 10 to the negative 7.54 times 9.52 times 10 to the negative 6. We're just plugging in the numbers there. And H plus concentration is going to be 5.24 times 10 to the negative 7th. And the pH then is going to be 6.28. And negative log of the H plus concentration, of course, is the pH, 6.28. Okay. So that should be a pretty straightforward chemistry problem. Acid-base chemistry. Make sense? Meg? You had sort of a furrowed brow, but that's good. Okay. Hit the lights for us again real quick, Jason?